A very warm greetings to everyone present in this meeting room. I am Dibiksha Shrestha, Secretary of Geomatics Engineering Students Association of Nepal GESAN, and I would heartily like to welcome you all to our first episode of Geo Talk series. Thank you so much everyone for joining us today. Now, moving on, for today's episode, we have our very special guest professor from China. She is Professor Ying Chen, and she is an associate professor at the College of Information and Electrical Engineering at China Agricultural University, and also a deputy director of the Key Laboratory of Agricultural Machinery Operation, Monitoring, and Big Data Application. Her research in data mining and natural language processing has driven innovation in agricultural technology, and also her accolades include the prestigious Chinese Agricultural Science and Technology Award and also the Beijing Science and Technology Award. And for today's episode, she will be delivering in the topic Big Data Mining and Application of Agricultural Machinery Operation based on BeiDou. Thank you so much, ma'am, for joining us. Are you there, ma'am? Hello, Professor.
Hello.
Okay, ma'am. Floor is yours.
Okay. So, thanks for the invitation of Professor Yumesh, and thank you for the assistance of Deepik Shah. Yeah, thank you so much. Good evening, everyone. So now I beginning my presentation. So can you hear me? Is okay? I should share my. Wait a minute. I should need to share my slides. Okay. Where is the? Oh, okay. Wait a minute. Wait a minute. I will. Yeah. So, can you see the my slides?
Yes, ma'am, we can.
Okay. Wait a minute. This is a Chinese. Sorry, it's a long slide. It's a Chinese one. I need to wait. Okay. So, can you see the slides?
Yes, ma'am.
Okay. Sorry. Okay, I'm Ying Chen. I'm from China Agricultural University. Today, I would like to present my team's work on the big data mining and the applications of agricultural machinery operations based on BDS. This is the outline of my presentation. The big data are all from agricultural machinery operations. First, I will introduce the background of our work. First is, what is BDS? It is a navigation satellite system independently constructed and operated by China. So it is very similar to GPS. Since provision of the service, BDS-based navigation services have been widely used in many fields in China, particularly in transportation and agriculture. The detailed introduction of BDS is given in this link, so you can see this link. Today, I will introduce the application of BDS to agricultural machinery. It is a field of combined transportation and agriculture. So the table and the figure, this table and this figure give an example of BDS data. Okay, the data were recorded by a BDS terminals, which has been installed on an agricultural machine. So look at this table. The table gives the data structure of BDS data. And look at this figure. This figure is a visualization of the BDS data. So let's look at the table again. And in this table, we can find that the BDS acquisition intervals is 5 minutes. 5 seconds. You can look. This is 5 seconds a point. Each row is a BDS record, which has 5 parameters. Is like time step, latitude, speed, and the directions. And we can see, look at this figure. In this figure, each blue is a BDS record. So it's a 1-to-1. Our work is supported by the project is National Precision Agriculture Applications based on BDS. The total amount of the project is 300 million China currency. Through this project, more than 700,000 machines have been installed BDS terminals in China. So this is through the terminals, huge amount of BDS data have been recorded during the operations of these agricultural machines. So this data also called agricultural machinery operation data. Meanwhile, through the project spot, my team also built a big data center and a big data system. In this big data center, there are about 30 machines. And this big data system, it is built on this center. It is to save, manage, process, and analyze the PDF data so as to real-time monitor the operations of agricultural machinery in China. Okay. Next, I will briefly introduce the big data system because it supports our big data mining and applications. Okay. To support the analysis and the management of massive PDF data, we have designed and deployed a big data system, which allows the integration and the use PDF data from different resources for monitoring our agricultural machinery operations. This figure gives the data flow. First, data were recorded by a BDS terminals, which has been stored on a machine. Okay, this one is BDS terminals. Okay. Then the data was sent to the Internet of Things platform centered here. These platforms were built by agricultural machines manufacturers for their product services. Okay, finally, the platform sent data to our big data system in this one. After verification from 2021 to 2024, our system can support co-accuracy access by 250,000 terminals and manage data from 1 million terminals. The detail of the big data system are given in this paper. This is a Chinese paper, so this figure gives the architecture of our big data system. In this figure, there are 5 layers: data source, data access, data storage, manage, data processing, and the data application. This is the data source layer. It collects data from BDS terminals installed on the agricultural machines. And this is the data access layer. It collects data from different things of Internet of Things platform use internet communication technologies such as gateway, Kafka, this technology. For data storage and the management layer, it efficiently store and manage data using distributed data processing frameworks such as Hadoop and Spark. For data processing layer, it processing and analyzes data using different data mining technologies. For data application layer, it focuses on the statistical analysis and the visualization of data analysis for specific applications using these technologies, such as heat map, diagram of operation gravity center, and operation time, and this kind. In this presentation, I will focus on the data processing and the data application layers. Next, I will present big data mining technologies used in our data processing layer. Okay. This figure gives the 4 steps in the processing of a single trajectory, where a trajectory refers a sequence of points recorded in 24 hours from a machine. Okay, first step is data cleaning. It mainly smoothing noisy points and remove duplicate points to provide a high-quality trajectory data. For example, this point is a noise point. It is needed to be removed. Okay. Second step is field road trajectory segmentation. It segments a trajectory into a sequence of segments and classify each segment as either a field segment or a road segment. In this figure, these blue segments represent the machine is in field, while the road segment, this road segment, indicate the machine is on road. So we need to segment this trajectory. Turning recognition, it identifies the turning behavior of agricultural machine within a field. This segment is a field, and the red point indicates the machine is making a turn. So, okay, this point. Finally, is the operation evaluation calculation. It calculates the effective operations of a machine using its field segment, such as operation time, operation distance, and operation area. So this one is a field, and we need to calculate its area. Our data processing can be considered as a dimensionality enhanced study. For example, okay, firstly is field road trajectory segmentation. It focused on processing individual trajectory point. So it is a 0-dimensional analysis. And then for operation time and distance statistics, targeted a segment. This is a segment, is a line. So it is a 1-dimensional analysis. And operation area calculation is analyzes a field. So it's a plane. So it is a 2-dimensional analysis. Farmer income analysis incorporates a monetary dimension. So it is a 3-dimensional analysis. And for example, is a policy regulation. It adds a regulation dimension. So it is a 4-dimensional analysis. So from this example, we found as the dimension increases, the trajectory data becomes more valuable and meaningful, providing deep insight into agricultural machinery operations. I will provide the detail of the field road trajectory segmentation because it is the core part of our data processing. For the big data processing, because the large scale of the data it is necessary to have a good balance between effectiveness and efficiency. First, we look at the time requirement of our data processing. At every midnight, we launch a program. It processes all data recorded in that day and generates a daily report about the operation status of the nationwide agriculture machine. The report must submit to governments before 8 a.m. on the next day. So, all data processing must be finished in 6 hours. After our 4 years verification, our data processing can process about 8,000 trajectories in 6 hours. Okay. Then, among all processing, the most time cost process is field road trajectory segmentation because it involves a lot of AI processing. Considering segmentation, effective and efficiency, we proposed a hybrid field road trajectory segmentation. This figure gives the flow chart of the hybrid segmentation. In general, there are 3 steps. The first step is trajectory. This one is a trajectory quality classification. It assigns a label to each trajectory, high quality or low quality. Okay, for example, this is a trajectory. It is a high quality. This one is also a trajectory, but it is a low quality. It's very different. And the classification is based on the acquisition intervals of the trajectory. If the acquisition interval is 5 seconds or less, the trajectory is high quality. Otherwise, it is low quality. Step 2 is algorithm selection. Depending on the quality classification, different existing field road segmentation approach are chosen specifically for high quality trajectories. A DB scan plus rule algorithm is chosen. DB scan is a density-based clustering method. This method is time efficient, but is sensitive to the trajectory quality. For the low quality trajectory, a GCN-based algorithm is chosen. GCN is a deep learning method, which is designed to learn representations from graph data. And this approach is less sensitive to variation in trajectory quality, but it requires more processing time. Finally, the step 3 is a chosen application algorithm is applied to obtain the segmentation result. For example, the green segment is a field segment, and the purple is a road segment. The detail of the hybrid field road segmentation algorithm is given in this paper. Let's briefly introduce the DBScan plus rule segmentation algorithm. It mainly utilizes 2 characteristics of the agricultural machine point distribution. We can look at this figure. When machine operates in fields, it typically travel at a very slow speed. And in construct, its speed on road, this is on road, the speed is very fast. So this results a significant difference in the density of trajectory point between field and the road areas. Okay, we can look, this is a field area, and this is a road area. So the densities are very different. To address this, DBScan is employed to cast trajectory point for effective segmentation. So this is step 1. That one. Second, within a field, this is a field. Agricultural operations often conduct in a strip, so leading a parallel distribution of trajectory points. And look at this field. And for the yellow point, their directions are parallel. So In this paper, in our paper, with specific rules are designed to correct previous segmentation errors. So this is a two-step. One is use the DB scan, another is then use the rules, correction rules. The detail of the DB scan plus rules segmentation are given in this paper. And this segmentation algorithm is very efficient, but its performance is unstable. It is sensitive to a variation in the trajectory quality, particularly to the DBS data acquisition frequency. Next, I will introduce the GCN-based segmentation algorithm as shown in this figure. It is the flowchart of the GCN-based segmentation. There are 4 steps. One is input feature extraction. The second is spatial temporal graph construction. And the third is the graph conversion process. And finally is linear classification. So, giving a trajectory. For each point, eight motion features are extracted to represent this point. So, this is the input feature extraction. Okay. Second, a spatial temporal relation graph is built through using the spatial and the temporal correlations between adjacent points. So this is a graph is built. Then using the graph, a graph convolution network is used to perform feature propagation, and a new representation is learned for each point in this graph. Finally, a point is classified as either a field point or road count based on the new features learned from the GCN. Okay. This segmentation algorithm performs good and stable, but it is not highly efficient and requires GPU computation resources. The detail of this algorithm is given in this paper. We have introduced the 3 segmentation algorithm: hybrid, DB-scan plus rules, and the GCN. And in these slides, we present the effective and efficient of the 3 field road segmentation algorithm. First, we present the effective of this algorithm on 2 data. One dataset is weight harvest dataset. It contains 150 trajectories, and another is a petty harvester dataset. It contains 100 trajectories. The grand choose segmentation of this trajectory are given by human, and the performance is given in this table. In this table, we can find the GCN algorithm performs best, maintain a very stable segmentation result, and his performance is about 85%. In construct, the DB scan plus rules perform varies and is less stable. You can say that this accuracy is 84, and in the petty dataset is 71. So its performance is unstable. Next, we present the time consumption of the 3 segmentation algorithm use about 28,000 trajectories. The data are recorded in 24 hours in June 2022. And in this figure, the green line is the DB scan plus rule algorithm and has the best efficient. And the orange line is a hybrid segmentation. And the purple line is the GCN-based segmentation algorithm. It is lowest efficient. And also look at this figure. We can find when the number of trajectory exceed 5,000, the hybrid, the orange line segmentation begin to demonstrate significant advantages in the processing speed. So overall, the hybrid segmentation algorithm achieve a good balance between effective and efficiency. Okay. Next, I will present the big data applications. Okay. Since 2021, my team began to compile a product called Weight Harvest Express. So the machine type is weight harvest. And the data from 4 manufacturers, and this is 4 manufacturers. And each time the process data is recorded in 24 hours. The time is one day, noon, to the next day also is noon. So this is 24 hours. Before we release our Express, the monitoring of a nationwide weight harvest operation in China relies on the statistic data provided by local governments. It is offline and sometimes incorrect. And using our Express, the monitoring is a shift from quantitative to quantitative, and from macroscope to the macroscope, and from offline to real time. It represents an application of big data in the field of agricultural machine. And in the following presentation, I will present some contents in the Express. Okay, look at this. This is a heat map of weight harvest in 2022. As the day passed, the heat place moved from south to north. We found the governments are very interested in the heat map. Through the heat map, they know the activeness of harvest in China every day. Okay, this one. This is a 2 operation gravity center figures for weight harvest in 2022 and 2023. This is 2022 in this figure. In 2022, the weather was norm, so operation gravity center moved in a zigzag pattern from south to north. No, it's normal. And in 2023, due to the impact of excessive rainfall, the movement of operation gravity center existed a chaotic pattern, so it's very noisy. This is abnormal because of the weather. There are 2 figures in this slide. The left one is the average operation time on every day in the weight harvest season in 2022. So, and this one, this is the operation efficient of a nationwide agricultural machine in a day in 2022. This is a 1 day. This is a whole season. And both of them provide quantitative statistics of weight harvest operations. So, come like this figure. This table lists the information of top 10 weight harvesters. And these harvesters are ranking according to their operation areas. Harvest operators are very interested in this table. Through this table, they can guess their own operation ranking in China. We list the name, location, operation area, operation time, and and we also give their operation trajectory. So, there are 2 figures in this slide. The left is a season champagne in 2021, and the right one is the daily champagne in 2021. Okay, you can see they have a different area distance. Through our recommendation, CCTV News, the news channel of China Central Television, reported the season champion. Finally is a summary and outlook. We have built a BDS-based big data system and its product, Wet Harvest Express, which enable real-time monitor of wheat harvest in China. This is very important for government. And we also develop a hybrid field road segmentation algorithm that can accurately and efficiently segment the trajectory into field and road segments. This is our core technology. And in the future, we will also deploy more information products to enhance the search capability of our data. And meanwhile, we also wanted to integrate our data with other data, for example, remote sensing data to improve the capability of data analysis model. Okay, thank you for listening. Chen.
Thank you so much, ma'am, for this very informative session. Now, next, we would like to move towards our question and answer session. So, for this session, we have asked the participants to drop their question in the chat box. So, I would like to read the questions for you, and then you can answer them one by one. Is it okay?
It's okay. Okay.
Okay. Now, we have our first question from Sangeet Belvase. So it is, how does the use of BeiDou compare with the other GNSS systems like GPS or Galileo in terms of data quality and application in agricultural machinery?
You mean the BeiDou and the GPS?
Okay, I can read it again. So the question is, how does the use of BeiDou compare with the GNSS systems like GPS or Galileo in terms of data quality and application in agricultural machinery?
Okay. I guess it's not there are no big difference. I think because GPS there are few agricultural machines install GPS in China, so we cannot collect so much data in China. And BeiDou BDS because it's government support the install of these terminals. So I think it's no different. Okay, that's all.
Okay, thank you, ma'am. Next question we have from Gaurav Baral, and it is there a way to make these technologies accessible and beneficial for small scale farmers? And how can big data and BeiDou be applied in areas with limited resources?
You mean the limited resource is limited resource refer to what is your what do your limited resource refer to? Is it computational resources or others?
I guess it refers to small scale farmers who have limited resources in terms of.
In fact, for example, in China, so all this computation, data processing is finished in our data center. So we can send back the result to the farmer, I think. Or they can access their information on our website. So they do not need any computation resources. But they must install BDS, I think, their machine.
Okay, ma'am. Moving forward, next we have from Sudeep Khanal. What advancements do you see in the near future for agricultural technology, especially with satellite navigation systems?
Future work? You mean, pardon, can you speak again?
Okay, I can read it again. What advancements do you see in near future for agricultural technology, especially with satellite navigation systems?
Oh, okay. We wanted to let's see, it's a one project we are working on, and we also use the GPS, we call BeiDou, and we wanted to monitor the fuel consumption of the agricultural machine. We combine the BeiDou data with other data from the data from other sensor, like the fuel consumption in the machine. And we know which machine, which agricultural machine worked a lot and cost less fuel. This is one direction we are working.
Okay, ma'am. Shall I move forward?
Uh,
Okay. Next question is from Sachin, and the question is: what pre-processing steps should we consider before applying DV scan or GCN to ensure the best results for agricultural data?
you mean the pre-processing?
Yeah.
We know we should do the data cleaning. Other is okay. Data before apply the field road segmentation, we need to do data cleaning because sometimes there are noisy data in the trajectory. We need to remove this or correct this noisy data. No other processing, data processing. Okay, that's all.
Okay, ma'am. Now, last question is from me. It's a little out of topic, but still I want to ask it. So, for students like us who wants to pursue their masters in China, what can be the process? Like, how can we apply for our master's degree in China?
Uh, um, for our university, there are you need to apply. How to say? There are international students. Uh, there are a lot of international students. You need to apply through. I do not know the detail, but I can ask and I will send back. Yeah. No, I'm not very clear the processing how to apply, but I know there are a lot of international students. Okay.
Okay, ma'am. And do you know about like scholarships, how they give us scholarship for international students?
I can ask. I can ask for it. Sorry.
Okay, ma'am, no worries. I think that's all for this sessions also. Um, okay, we have addressed all the questions. Now, again, thank you so much, ma'am, for joining us today and delivering this very informative session. Before ending, we will like to express our sincere appreciation towards Department of Geomatics Engineering, IOE Postmantle Campus, and our very own Head of Department, Umesh Purtel sir, for making this possible. And also a very special thank you to Hanning for making every step easier. Thank you so much, Hanning. And last but not the least, thank you to our participants for joining us today. And okay, now before ending, can we open our camera so that we can take a group